Hello, calculus students. In the last lesson, we looked at the power rule as a way to find the derivative. That replaced the limit of f of x plus h minus f of x all over h as h approaches 0. So that power rule, we moved the exponent to the front and subtracted 1. I have a few more rules for you about how to solve derivatives, how to find derivatives. So today we're going to find the derivative of a function for sine, cosine, logs, and exponentials. That's a lot to put together, but be patient, we'll get there. Before we jump into the derivatives, I just have a few log and exponential rules to remind you of. Take a second now and try to come up with these. The natural log of 1 is actually 0. The natural log of 0, if you attempt to put that into your calculator, and I'll just hold up my calculator and trying to do instead of a screen share. If I put natural log of 0 in my calculator, I get a domain error. The reason why that happens is because it doesn't exist at 0. So if I draw in a little natural log curve down here, this is the natural log of x. It will never, ever, ever touch x equals 0. So we have to look at limits instead. Technically, it doesn't exist. Depending on what you're doing, you can think of it as negative infinity. So technically, it doesn't exist if you're looking at the actual value of the function, natural log of x at 0. But if you're looking at limits, you would consider it negative infinity. E to the 0, well, anything to the 0 power is 1. E to the natural log of a, when that simplifies, that will become an a. And ln of e to the a will also simplify to an a. So those are just some exponential rules to remember. Now, derivatives. I'm not going to show you where these come from. If you really, really want to know, you can look them up on YouTube. There are many videos about it. But the derivative of sine will become cosine. The derivative of cosine will become negative sine. The derivative of e to the x is e to the x. The derivative of a to the x is a to the x ln of a. The derivative of natural log of x is 1 over x. The derivative of log base a of x is 1 over x ln of a. That is a lot. Now, here's the thing. They must be memorized. There are no ifs, ands, or buts. There's no way around them. Don't bother trying to program them into your calculator. You must memorize them. You gotta know them inside and out. Now, truthfully, you'll use them enough that they do get ingrained in your brain. I will share with you, I used to photocopy this on yellow paper to give to my students, but I'll share it with you in our Google Classroom. I call it the golden ticket. One year I accidentally photocopied it on yellow. It was about the same year that Johnny Depp Willy Wonka movie came out, and somebody said, hey, look, it's our golden ticket. And so it just kind of stuck. This will be the list of derivatives that you are responsible for knowing. So today we're talking about sine and cosine over here on the left. This is a little out of order from what we used to do, but that's okay. Over here on the right, we have some logs and exponentials. So I highly recommend you print this out for yourself and start to fill it out as we learn those derivatives. It's a quick reference sheet for you. On the back of this are integrals. We'll get there, I believe it's unit 5 or 6. We will get there later, but this will be your quick reference sheet. There is no formula sheet for the AP exam. There's not. I wish there was, but there's not. Statistics gets one, physics gets one. Calculus does not get a formula sheet. So we can do it though. Lots of students have done it before. More will continue to do it. You can do it. All right, let me share my screen again. Hopefully we're in good shape. So what do these look like when you go to find the derivative? Example 1, find f prime of x if f of x equals 3e to the x plus 2 to the x. Now, see if I can fit everything in here. Yeah, I guess I can. Basically, you have to use the formulas that are up above. So f of x equals 3e to the x, 2 to the x. So f prime of x, label, this is f prime of x. I don't want to see just a random equal sign. You must write this part in here. It's going to be so important later. We're going to have other derivatives. You have to keep your work organized. The derivative of 3e to the x, I look up here, is e to the x. So this is 3e to the x. 2 to the x, that's really the a to the x formula. So this will be 2 to the x ln of 2. That, my friends, is the answer. I'll just write it a little neater down here. There's nothing else to do. There are no like terms to put together. Sometimes students forget their algebra rules and they try to do crazy things. That's it. That's as good as it gets. For example, 2, find f prime of x if f of x equals 4 ln of x minus log base 4 of x. Those formulas are here. So f prime of x is going to be, that 4 is a coefficient, it just sits in the front. The derivative of natural log of x is 1 over x minus log base 4 of x. So this would be 1 over x ln of 4. This 4 counts as your a. Again, I'll rewrite it. I'm going to combine those first two, call it 4 over x minus 1 over x ln of 4. And that's it. There are no like terms to combine, nothing to do, nothing to subtract. Leave your answer as that. Example 3, find f prime of x if x equals 4 cosine of x minus sine of x over 2. So I know I scrolled my formula up a little bit. Cosine is here. Oops, sorry. Cosine is here. The derivative of cosine is negative sine. So f prime of x is going to be 4 times negative sine of x. Now, this sine of x over 2, switch colors, is really the same thing as negative 1/2 sine of x. Kind of think of it as being multiplied by 1/2 there. Then this would be minus 1/2 cosine of x. Yeah, you know what? I'm going to undo that piece. I'm going to rewrite this. I'm going to put the negative sign in the front. I don't want it to accidentally look like subtraction. So negative 4 sine of x minus cosine of x over 2. There you go. I like that one. Again, you can call it cosine of x over 2 or 1/2 cosine of x. Either one is fine. In example 4, find f prime of pi over 4 if f of x equals 2 sine of x minus 4 cosine of x. So I've got to find the derivative first. The derivative of sine is cosine. The derivative of cosine is negative sine. Those coefficients, the 2 and the 4, just sit in the front. So f prime of x is equal to 2 cosine of x plus 4 sine of x. Now there's something a little bit different in this problem, and that's this pi over 4. So now we need to find the derivative and evaluate it at pi over 4. So f prime of pi over 4 is going to be 2 cosine of pi over 4 plus 4 sine of pi over 4. Well, now this is where you got to know your unit circle. And I know sometimes we're feeling a little bit rusty on our unit circle, but pi over 4 is in the first quadrant. The ordered pair is root 2 over 2, root 2 over 2. Cosine and sine have the same value there. So this is 2 root 2 over 2 plus 4 root 2 over 2. This simplifies to be root 2 plus 2 root 2. Now these we can add together. These are like terms. This is 3 root 2. F prime of 4. Pi over 4, excuse me. There you go. There's the derivative evaluated at pi over 4. Here's another thing that we have to look at, and that's our piecewise functions. In order for a piecewise function to be differentiable at a point, all of the following must be true. It must be continuous, and I know we had some problems about that in the last section where we were looking at continuity, and the derivatives of the two pieces must be equal. What we're really saying is derivatives, this has to be equal slope. And that's because you want a smooth transition. You want to switch from one piecewise function to another with a smooth transition. You can't have a parabola and then it switches to a line. This point is not differentiable. But as long as you have a curve, maybe a parabola up and then a parabola down, as long as you have a smooth transition between the slope, it is differentiable. All right, so I had to take a little break there. Sorry about that. Example 5, is the function differentiable when x is equal to 5? So in order for it to be differentiable, first it has to be continuous. If you have a function that's not continuous, you have to stop the problem. So let's start there. let's look at the this function at 5. And so we're going to do the left-hand side here. So we want the values less than 5, which is the first one. So this will be 2 times 5 minus 8/5 times 5 squared minus 10. This will be 10 minus 40 minus 10. So what do we got here? This will be negative 40. Double check my math. I might be wrong. I'll go back and check in a second. And then you also have to check on the right-hand side. Now, I know in pre-calculus that this piece where we have x is greater than 5, you wouldn't use that, but we need the curves to match. So we're still going to put 5 into the second piece. So I have 50 minus 14 times 5. So quit. 14 times 5 is 70. So I have 50 minus 70 gives me negative 20. I'm guessing I have a math error in the first one too. 5 minus 8. 25. 40 minus 10. They don't match. All right. I'm going to have to go back and fix this example. I'll go back and alter that in a second, but let's pretend that the y values are the same. I want to know if it's differentiable. So I need to find the derivative of each one. So I'm going to find the derivative of the first piece, f prime of x, and this is the left. We're going to call this 2 minus 16 over 5 x minus 10. And then on the right, f prime of x is a negative 14. So the first one, we want to evaluate at 5. This will be 2 minus 16 over 5 times a 5 in there. This gives me a negative 14. And the second one gives me negative 14. So they do have matching slopes. So that's good news. And if these y values were the same, then we could say it's differentiable. But the way that this particular one is set up, these two problems, these two slopes match, which is great. There would be a smooth transition. But unfortunately, in this problem, they'd have matching slopes, but there'd be a gap from here to like here. It would look something like this. So technically not differentiable, even though the slopes match. So keep it up and make sure you ask me questions. All right, sometimes mistakes happen and you got to go back and adjust. So example 5, I erased the first part. If we make this a plus 10, things actually work out. So make this a positive 10. So now let's try again. If I try from the left, f of 5 is 2 times 5 minus 8/5 times 5 squared plus 10. This would be 10 minus 40 plus 10 is a negative 20. If we try from the right, this is f of 5. Now we want to put it in this piece that's a little bit bigger. This is 50 minus 14 times 5. 14 times 5 is 70. So we've got 50 minus 70, which is a negative 20. So now the y values match. So that's great. It's a continuous function. So step 1, it's continuous. Then we can go into this other conversation of step 2. Do the derivatives match? Is it differentiable? Yes, the derivatives match. Therefore, the slopes match. Therefore, it's differentiable. It's a smooth transition. So this one's good to go now. If you make this a plus 10 right there. All right. Good job. Thanks for your patience. Keep asking questions.